Okay, our last equation, I'm going to change it from what it was to this. I just want there to be a number in here too. This has everything happening to it. It's going to have the vertical reflection, it's going to have the horizontal shift, it's going to have a vertical shift. But again, our initial step is to establish the type of function it is. This is an absolute value function. If I focus on the absolute value of x, the parent set of ordered pairs, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. I start at the parent graph. So, -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. I connect those. Again, where the sharp turn happens, I want to go this way with an arrow. I want to go that way with an arrow. I do not want to have an arrow right here at the dot. So it just basically, what happens is the absolute value takes this linear function and it reflects that up there. So that causes that sharp turn. Okay, now we got three things happening. I want to focus on all three things, and I'm going to modify each point based on the three things happening in this exact order. Step one, the minus sign right there causes a vertical reflection. Number two, the -2 inside the function is going to create a +2 horizontal. Okay, and again, if it's happening inside the function, so it's an absolute value function, inside the absolute value bars there's a -2, it does the opposite horizontal. -2 is a +2, moving it horizontally. And the last thing, it's got a +3 outside the absolute value bars. That creates a +3 vertical. Vertical is exactly what you see. +3 means it moves up, -3 moves it down. I'm going to do all three things to all 5 points to create this new graph. So if I go through the three pieces here, and I'm trying to graph this f of x. All right, first off, I'm going to start with this point here. There's my original point, -2, 2. I'm going to reflect it vertically, so it's 2 above, now it's 2 below. Then I got to move 2 spaces right, 1, 2, and 3 spaces up. So that point became this point. Second point, I'm going to do the same deal. There's the point I'm dealing with. First, I reflect it vertically, so it's 1 above, now it's 1 below. 2 spaces right, 3 spaces up. It becomes this point. The third point, which is right here. First of all, reflect it vertically. 0 stays at 0. It goes 2 right and 3 up. That becomes this point. The fourth point, which is right here, I reflect it vertically. It's 1 above, now it's 1 below. I go 2 spaces right, 3 spaces up. It becomes here. And my fifth point, see, I'm running out of colors here. Let's go with orange. This point, vertical reflection, so it's going to go 2 spaces above, 2 spaces below is reflected, 2 spaces right, 3 spaces up. So these 5 points become those 5 points, and my graph becomes this one. And that's going to be F. And this, of course, was P. Again, always do reflections first. If there's a minus sign, reflect first, and then move horizontally and or vertically, whichever order you want to. If I had gone, for example, this point, reflected here, vertically 3 spaces, horizontally +2, I still would have been at the same spot. It doesn't matter what order you do these to it, but always do the reflection first. If I move 2 spaces right, 3 spaces up, and then reflect, all of a sudden I'm way down here, that's not going to be right. All right, so reflect first, and then the horizontal and vertical movements. But everything that modifies the function, here's what it started off looking like. Anything that makes it look different, a minus sign, a -2, a +3, all those things create differences. Minuses flip, plus or minus in here moves it horizontally, plus or minus out here moves it vertically, horizontal opposite, vertical exactly what you're looking at. Okay, the best way to do this is to practice it, so there's 4 example problems on the back, give it a shot, see how it goes.